Now into the guided practice. So our first one, not dealt with anything with a p, so I'm typing this in a calculator. 11 factorial over parentheses 11 minus 3 factorial. So we'll put your fraction up there first. Eleven factorial, narrow it down, parentheses 11 minus 3, close your parentheses, and then put your exclamation mark, factorial sign. Then we get 990. Number 2, I'm looking at NCR 11,3, or you can type that in your calculator. So menu probability combination 11,3, and we get 165. The next one, there are 23 students in a high school geometry class. The students are tasked to form a group of 5 representatives. How many different groups can be formed? So these are just groups, so order doesn't matter. Which means that we're using a combination. We need to find our total, which is 23. And how many we're choosing, which is 5. So we've got NCR 23,5. So my calculator, menu probability combination 23,5. And we get 33,649. Possible groups. The next one, Lufkin's junior varsity basketball team has 12 athletes on their team. If the coach chooses at random 5 players to start the game, then how many different starting lineups are possible? So these are just groups. They're not assigning positions to the players. So order doesn't matter. So we're using a combination. So we have a total of 12 players, and we're choosing 5 players to start. So we've got NCR 12,5. So again, menu probability combination 12,5. And we get 792 possible starting lineups. Number 5, if 3 points are randomly chosen from those on the Pentagon shown, what is the probability that they all 3 lie on the same line? So we need to know how many we have, because again, order doesn't matter. Because it doesn't matter what order we choose the points in. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total points to choose from. And we want to choose 3 of those points. So we have NCR 10,3. And menu probability combination 10,3. You get 120 possible outcomes. But we're not finished because we want to know what the probability is that they all three on the same line. So we have 1 set, 2 sets, 3 sets, 4 sets, 5 sets. So our probability is 5 out of 120. Make sure you reduce your fraction. And get 124. Number 6, the Texas two-step lottery has 2 steps in choosing numbers. Step 1, choose 4 numbers without repeating digits from 1 to 35. The order in which the numbers are chosen does not matter. Step 2, choose one bonus ball. That can be any number from 1 to 35. What is the probability of winning jackpot? So we have 2 steps to this. Again, order doesn't matter, so this is a combination. The first one, we have 35 balls to choose from, and we want to choose 4 of those balls. So we've got NCR 35, 4. Menu probability combination 35, 4, parentheses, enter, and we get 52,360. So that's the first step. The second step, we are choosing one ball. So there's only one spot, and there are 35 options for that spot. So we have a first step and a second step. Now to get your total, you need to multiply those together. So 52,360 times 35. And we get 1,832,600. Possible tickets. But we weren't looking for how many tickets are possible. We're looking for the probability that that specific set, 34, 15, 2, 3, and a bonus ball of 17 are the winning number. Well, there's only one way that those are the numbers. So it's 1 out of 1,832,600. Number 7, how many lines are determined by 10 randomly selected points where no 3 of which are linear? So again, order doesn't matter here. And we have a total of 10 points. Now, how many points are we choosing because we are making a line? 2, because 2 points determine a line. So we have NCR 10, 2. Again, menu probability combination 10, 2, and we get 45 possible lines. And yes, you need your descriptors when you're writing it down or you're typing it in